Welcome to Lecture 2. Today we will take a look at the most basic encryption algorithm, the ShiftCipher. A form of the ShiftCipher was used by Julius Caesar.
Hi, it's Alice again. Julius Caesar used one of the earliest examples of an encryption algorithm. While conquering Gaul, he sent messages back to the people in Rome. Problem was that the Gauls could capture his messengers. So, what could he do? Well, let us start by pretending. Imagine I was Julius Caesar. How would I protect my messages? There you go. Julia. Caesar. I start by writing down the message I want to send back to Rome. The original message is called a plain text. We now make a dictionary for encryption. We start by writing down all of the letters. And now, let us shift the letters by 3. So A becomes D and so on. Next we take each letter in our original message and shift them. Watch as we do this. The encrypted message is called the ciphertext. Now we send our message back to Rome, where Bobicus will decipher the message and read it to the people of Rome.
Julia has sent me a message. It is encrypted using our favorite cipher. To decrypt it, I have to shift each letter back. Let us see how we do this. Now we make the decryption dictionary. To do so, we write the shifted letters, and then unshift them. To decrypt, we take the ciphertext and we unshift each letter. This gives us back the original message.
You might ask, do we always have to carry around a dictionary? Or perhaps can't we do this with math? The answer is, of course, yes. We take each letter and assign it a number. We start with A equal to 0, B equal to 1, and so on. All the way up to Z equal to 25. To encrypt a message, we convert each letter of the plaintext into a number. For example, Gaul becomes 6, 0, 20, 11. Next, we refer to one of the letters using the variable x. So, for example, let us say x equals 6, then x really corresponds to the letter G. The encryption key is how much we shift each letter by. We use the variable k for the key. In our case, k equals 3. To make the ciphertext, we simply add x and k modulo 26. We use the variable y to represent the ciphertext. So y equals x plus k modulo 26. We do this for each letter of our plaintext. So Gaul would become 9, 3, 23, 14. Finally, we convert these numbers back to letters. This gives us the ciphertext for Gaul as J, D, X, O. If the plaintext was the variable x, and the ciphertext was y, decryption takes the ciphertext and the key, and gives you the plaintext. This means we solve for x given y and k. So when Bob gets the letter J, he sets the variable y equal to 9. He uses the key k equal to 3. And he solves for x. X equals 9 minus 3 modulo 26, which is 6. Finally, he converts 6 back to a letter, which is the letter G in Gaul. In the next lecture, Eve will teach us how she might go about breaking Julia's message to Bobicus.